In this video, we're answering the question, why can't we divide by 0? My name's Ryan, and I'm going to be using Desmos to solve this question. So right over here, we have the graph of y is equal to 1 over x. Now, when I'm talking about dividing by 0, well, we know how whenever we have a fraction, right, we have some number divided by another number. And in the fraction, for some reason, our denominator can be, let's say, 2, it can be 3, but it can never be 0 for some reason. And I want to kind of find out why that is. So in order to explain this, what I'm going to do is, instead of dividing 1 divided by 0, I'm going to divide 1 by a number that's very close to 0. And let's see what happens. So let's say if I divide 1 by 0.1, what am I going to get? I'm going to get 10. You can plug this into your calculator. 1 divided by 0.1 is 10. Now, what if I divide 1 by 0.01? What is this going to be equal to? Once again, you can get a calculator out, but this is equal to 100. What about if I divide 1 by 0.001? What is this going to be equal to? This is going to be equal to 1,000. And you kind of see the pattern here, right? As you divide by numbers that are closer and closer to 0 on the positive side, well, our result is going to be a very, very big number, right? Imagine if I divided 1, you'll notice how, when the numbers get smaller and smaller, they get closer and closer to 0 on the positive side. You notice how the result is getting bigger and bigger. So imagine what the result will be if I divided 1 by, let's say, 0.000, let's say like 20 zeros, and then like a 1 in front, right? This will obviously be a very big number. This will be a big number. And if you take a look at our graph, well, that seems to be the case, right? When we divide by numbers that are very close to 0, right? When x kind of approaches 0 on the positive side, right? Because remember, we're dividing by positive numbers that are close to 0. So when we divide by positive numbers that are closer and closer and closer to 0, you notice how our result, aka our y value, gets super, super big. So the whole point of this is to show that as you divide by numbers that are closer and closer to 0 on the positive side, well, our y value, aka the result, is going to be a very big number. And in calculus, you would say that the limit as x approaches 0 from the positive side of 1 over x is equal to infinity. So what this basically means is, if we're talking about the function y is equal to 1 over x, and the x value approaches 0 from the positive side, well, what's going to happen is, well, our y value, so this y value right over here, is going to approach infinity, right? Imagine how big the number would be if I had let's say, infinite amount of zeros and then just like a 1 at the end, right? This would be a very, 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 very big number, and it would just keep getting bigger because you can always add more zeros into this fraction, right? And the reason why this approaches infinity is because, well, if you have, let's say, 0.00001, well, the thing is, we can always add more zeros, right? If I have this fraction, if I take this fraction right over here, I can always add more zeros like this, so, and I would just get an even bigger number. So the reason why this function, as x approaches 0 from the positive side, the reason why this approaches infinity is because I can keep adding zeros to this denominator, and I will keep on getting a bigger and bigger number. So that's the reason why this approaches infinity. Now, what if I divide by numbers that are close to 0 from the negative side? So let's say if I divide by, let's say, 1 divided by negative 0.1, right? Because negative 0.1 is also close to 0, right? So I want to see what happens there. Negative 1 divided by negative 0.1 is negative 10. 1 divided by negative 0.01, that is negative 100. Once again, you can kind of see a pattern forming, right? As you divide by negative numbers that are approaching 0 in this function, well, you're going to get greater and greater negative values, right? So as you divide numbers that are closer to 0 on the negative side, well, you're going to get a bigger and bigger negative number. And that's what you see on the graph here, right? You'll notice how as x approaches, so let me write this down. So as x approaches 0 from the negative side, so for those who are wondering, quick interruption. So basically, you notice how this thing is kind of split into like two sections, right? This part right over here is the negative side for our x-axis, right? Because the x values all over here are negative, right? And then the other side, these are positive x values, right? The 5, 10, 15, 20, and then the other side is -5, -10. So yeah, this is the negative side, this is the positive side. Just a quick clarification. So as x approaches 0 from the negative side, well, for this function, this is going to be equal to negative infinity, right? A very big negative number, right? So if you divide, let's say, 1 by negative 0.020 zeros in a row and then 1, well, this is obviously just going to be a very big negative number, like we saw before. And once again, the thing is, I can keep adding zeros, right? I can add 30 zeros inside here. I can add 40 zeros, right? There's no limit to the amount of zeros that I can add inside this denominator, which is why this number right over here is going to get infinitely bigger. And, infinitely bigger. So what we kind of concluded from kind of these two experiments is that, well, as x approaches 0 from the positive side, well, it goes towards infinity. And as x approaches the negative side, it goes towards negative infinity. So that means if you divide by 0, it's going to be positive infinity and negative infinity at the same time. Well, the thing is that infinity, first of all, it's not a number, right? It's just a concept. When you divide closer to 0, right, numbers that are closer to 0, you get closer to infinity, but infinity itself isn't an actual real number, right? So if 1 divided by 0 is equal to infinity, then does that mean that, infinity times 0 is equal to 1? In addition, this thing also creates contradictions. I right over here have the graph of y is equal to 2x. And right up here, I have the graph of y is equal to 1 divided by x. The other one is y equals 2 divided by x. And you notice how, let's just assume that 1 divided by 0 is equal to infinity. Let's just assume this, because as x approaches 0 from the positive side, it goes towards infinity. Well, the same thing can be said for y is equal to 2 divided by x, right? Right, as x approaches 0, y value approaches infinity on the positive side. So that means that 2 divided by 0 has to be equal to infinity. So does this mean that 1 is equal to 2? So just dividing by 0 would kind of break math. And yeah, that's kind of like the reason why you can't really divide by 0. Can't really produce like a valid result. The idea of infinity is, just a kind of a way of describing limits in calculus. But it's not an actual number that can exist when you're doing calculations. So yeah, division by 0 is undefined.